Let's work through Secureum race number 5. In this race, it's all about this contract snippet, which contains a single contract, which is called in Secureum. And it implements an interface, which is called ERC1155. ERC1155 is a token standard, similar to ERC20 and ERC721. And the difference here is that ERC1155 implements or allows a single contract to both implement fungible and non-fungible tokens. And not only one of those, but basically any amount. You can have 5 fungible tokens and 2 NFTs or NFT collections in the same contract, basically, all managed by the same contract. And that is not very widely supported by a lot of wallets, as far as I remember, but it is a very useful thing, especially for games, for example. So let's take a look at question number 1, and it says that the in Secureum balance of function may be optimized by caching state variables in a local variable. So optimizing, meaning consuming less gas, by caching a state variable value in a local variable. B says that it may be optimized by changing state mutability from view to pure. And C says that it may be optimized by changing its visibility to external. So let's take a look at this balance of function. You can see in the code that we actually have 2 balance of functions. One of them is balance of batch. And the simple balance of function really does not do much. It has a require statement that ensures that the address, the account that we are checking the balance of for, is not equal to the 0 address. It doesn't allow checking the balance of the 0 address, which is strange because this is a view function anyway, so it wouldn't even really be necessary to do any check here, I guess, but that's fine. And then it returns the balance by loading the balance of the current ID. This is basically the ID of the ERC20 token within it, or an ID of a single NFT within this contract. And then it loads the balance of that account. So if this ID was the ID of a NFT, the balance would always be either 1 or 0. But if this is if this ID represents an ERC20, this balance could be anything from 0 to the maximum integer of uint256, basically. So are there any optimizations possible here? So it was asking about caching the state variable value, and we are only loading this state variable here, and we immediately return it. So there's not much sense in caching it because we just return it. There's no further loads of the same storage variable after that, so there's obviously no way to optimize this with caching. Next, it was saying that we should change public to external, and that would mean that it would no longer be internally callable, and that wouldn't work because, as you can see here, that balance of batch actually makes use of this function. So we cannot change this from public to external because then balance of batch would no longer be able to call this function internally. So this is not possible. And the next thing was that it wanted to change view to pure. And this is not possible either because we are actually touching storage here. We are reading storage. And if you read storage, you are accessing the state of the blockchain, and therefore you need to specify view as the modifier for this function, or as a, well, it's not a modifier, but it is basically telling the compiler that this is a view function accessing state, and therefore we cannot change this to pure, because pure means that it is not accessing anything except for the parameters, basically. So if this function would just do some calculations based on the parameters passed, then this could be pure, but instead this is actually loading the state of the current account, therefore this cannot be pure. And therefore in question 1, none of these things are possible or make sense to optimize this function, and therefore it is the none of the above. Let's continue with question number 2. And here it says that in the Secureum contract, array length mismatch checks are missing in some of these functions. And what are array length mismatch checks? Basically, when two arrays are being passed to the same function, it is often the case that both of these arrays are being iterated over with the same index. So let's say we have an array of addresses, and we have an array of numbers, of amounts, for example. And it would iterate over each address and load the according number at the same index. So at address 0, or at the index 0 of the addresses and the amounts 0 of the amounts, we basically have two values that belong to each other that we will work with together. And the expectation in this code would be that both of these arrays have the same length, because if one of them is shorter, then it would basically stop too early at one of them and it would not find any amounts for some of the other accounts. And that's kind of bad. Luckily, in Solidity, we have actually checks against that. There is an out of bounds check that prevents anything more from happening except reverting, basically. So we would attempt to load the index 10 of an array that has 5 items, it would just revert, and that's completely fine. But it is the general best practice to revert as early as possible in the code, because every time we are iterating through arrays and doing stuff, we are spending gas, and if it reverts at the end of the loop, then we would have spent a lot of gas for something that would never actually end up being in the state of the blockchain. So that's not so good. So that's why the general best practice is to check the array size early and make sure that both are of the same size, and revert if that is not the case. So let's take a look at each of these functions. We have balance of batch. This function is getting passed two arrays, accounts and IDs. We can see here that accounts I and IDs I, so the index is I for both arrays, so there's definitely an expectation here that both are of the same length. But we can see that before this loop, there's no checks happening at all here. So we can see that there's indeed a mismatch check missing. Then we have save batch transfer from. This is this internal function here. And again, we have two arrays, IDs and amounts. Amounts I is being loaded, IDs I is being loaded with the same index I. That means that there is again the expectation that both of these arrays are of the same length. There is only one check before this happens, which is the check ensuring that the address specified is not the 0 address, but this doesn't help with the array length, so there is also a check missing here. Mint batch, we have it right here. It also has two arrays, IDs and amounts. We can see here that the amounts are accessed with the index I again, and the IDs with the index I as well. And once again, we only have a check to ensure that there is no 0 address, but there is no check to ensure the array length is equal. So there's again the check missing here. And finally, burn batch. And burn batch 2, just like the others, has IDs, amounts. It accesses both of these arrays with the same index. And once again, there is only the address 0 check. So all of these functions are missing a array length check, even though you could argue that these internal functions with the underscore prepended, they might not need a check like this, because you might want the caller to check their input, because all of these functions are basically internal, so nobody from externally can call them, and there might be the expectation by the developer here that the caller of these functions, which would probably be an external function, so external to internal, and then some would call the external function and pass those arrays first to the external function, and the expectation might be that this external function should check the array lengths before before calling these internal functions. And the reason for that might be that it is possible that you would call these internal functions multiple times, maybe with the same arrays, and then it would be wasteful to apply the same check over and over again in the internal function. It would be better to just do it once in the external function. So that might be the expectation here with the internal functions. Well, we don't know that. This question just asked if a mismatch check is missing, and it is indeed missing in all of these. So we can say that all of the options are true for question 2. Continue on with question number 3, where it says that there are possible security concerns with the in Secureum contracts underscore safe transfer from function. And it says that one of these security concerns could be an incorrect visibility, so incorrect function visibility, which could be public, external, internal, private. And with this function being prefixed with an underscore, I would assume it to be either internal or private, basically. So let's see if that's the case. Then we have B, it is susceptible to an integer underflow. And C, it is missing a zero address validation. So let's take a look at the code of this underscore safe transfer from function. We have actually two functions that are called very similar like this. We have the safe transfer from function without the underscore, which is public, as you would expect. And it calls this underscored function, which you would expect to be private, but it is also public. And the thing is that this function has some required checks here to make sure that the caller is the owner or approved. And this safe transfer from function does not have this check, basically, but is still callable directly, just like the not underscored function, which basically means that this require statement, this check, would be bypassed by calling this function directly. And that sounds like something we do not want to have. We probably do not want anyone to call who is not an owner or not approved to make use of some other person's balance with the safe transfer from function. So I would say that it sounds like the option A is indeed correct. This is not correct. That is public. So what would it be instead? We have the choice between private and internal. Private would mean that any contract that extends this contract would not be able to call this function. It would only be available within this very same contract, and that doesn't really make sense. I would say this should be available to other contracts that extend this contract, and therefore I would put this as internal, basically. This function should have an internal visibility. Next, it said something about overflows. And we can see here that this is solidity 0.8, so we have native protection against overflows. And we can also see that it makes use of an unchecked block, which means that such wrapping of integers is indeed allowed. And we have a subtraction here, which means that if the amount is greater than the from balance, this would potentially underflow. And there is no other check of the amounts to make sure that it is not larger than the from balance. And therefore, yes, there is definitely a problem here. So basically, people could call this function with arbitrary amounts and transfer more than the from balance, that the balance that is currently held in the specified account would allow. So that is definitely bad news. And therefore, yes, there is an underflow happening here, which is a security concern. And then the last option was about a missing address 0 check, and we can see that there is indeed no address 0 check anywhere here. And that basically means that we could, for example, specify the to address as an address 0, and this would possibly cause us to accidentally burn tokens or burn the tokens of the person that approved the tokens to us. And that might not be what we want, so we might want to have a 0 address check here to prevent this from happening. And with that, we can go back to question 3 and say that it indeed has an incorrect visibility because it is currently public, bypassing some of the checks. Then B is also correct. It is susceptible to an integer underflow because of the unchecked block where the subtraction is happening. Then we have C. It is missing a zero address validation that could possibly allow us to burn the tokens. And that means that A, B, and C of question 3 are correct. Next is question 4. And it says here that the security concerns with the Secureum's underscore, so again an internal function, or intended to be internal function, underscore safe batch transfer from, is R a missing array length mismatch check. Now, I think this is the same function that we already checked in question 2. We already know that there is a array length check missing to make sure that both the arrays passed in have the correct and equal length. Therefore, we already know that A is true and is a potential security concern. Then next we have B, it is susceptible to an integer underflow, and C, it has an incorrect balance update. So let's take a look at the function. It does not make use of any unchecked blocks. That means an integer underflow or overflow is not possible. So what about balance updates? We have balances that are being loaded here. We are loading the balances ID from. This from balance is then the amount is subtracted from the from balance and updated with the same from variable. And then the storage holding the balance of the to account is then updated by adding the amount directly. So basically what you would expect this to be, just in a single line, and that's it. But the problem here is that this is not quite equal to this, because while this loads the current balance and then adds, or here it subtracts the amount, it does not actually update this, the actual storage variable. And that's a problem, because that means we can use this function to transfer the same balance that we have multiple times, because what the amount never gets subtracted from ours. Well, it got subtracted, but the actual storage value is never updated with this subtracted amount, and that is pretty bad. This is certainly a security concern, if not more. Therefore, we can say that C, an incorrect balance update, is true, but it is not susceptible to an integer underflow because there is no unchecked block, and we know that this is solidity 0.8. Moving on to question number 5. It says that there are security concerns with the Secureum Mismatch function, which are missing array length mismatch check. And once again, I think we already checked this in question 2. Yep. So we can already say that yes, the check is missing. Potentially this is a concern. Then we have B, which says there is an incorrect event emission, and C, that it allows burning of tokens. So let's take a look at the code. Does it allow burning of tokens? That would mean that the to address would be allowed to be 0. And we can currently see that what is being checked against address 0 here is originally the message sender. And that doesn't make much sense, because it would be quite weird for the message sender to be the 0 address. That normally shouldn't happen, because nobody has the private key to the 0 address. So instead of doing this check with the operator, this should do the check with the to address. But currently it doesn't do the check with the to address, and therefore when it updates the balance here to 2, this 2 could totally be the 0 address, and it could basically mint all of these amounts directly to the 0 address, never to be used again, basically. So yes, there is a possible security concern regarding this function being able to burn funds during minting, which you usually don't want to happen, I guess. And then we have another question about another option about the event emission. And is this event emitted by other functions? Yes, we have here the transfer badge, which has operator from address 0, so this is probably 2. So operator from 2 IDs amounts, and then we have operator from 2 IDs. We can see here that amounts and IDs are the other way around here. And do we have another example? Here we again have IDs amounts. So the mint badge function, which this is about, has amounts and IDs in this event emission the wrong way around, and therefore the event emission is incorrect. So B, incorrect event emission, as we have seen, is indeed the correct option. That is a security concern here. C, it allows burning of tokens because the zero address check is not done for the correct variable. And that means A, B, and C are correct for question 5. Let's continue on with question number 6, which says that there are possible security concerns with the underscore burn function, which could be a missing zero address validation. It could be susceptible to an integer underflow, or it could have an incorrect balance update. So let's take a look at the code of this underscore burn function. And it says right here, underscore burn, it gets passed in exactly one address, which is the from address from which we are burning from. You can see that there is indeed a zero address check for exactly this one address, so there's no zero address check missing because it's right here. Then we can see that the balance is loaded from the ID, so the current token ID, from the account that is being specified. So we are correctly loading the balance. We are then storing it within from balance within this local variable. Then we are subtracting the specified amount from this balance. And then finally, we are updating the very same variable, the very same storage variable that we loaded. We are updating it with the updated amount. So this balance update is also correct. And we can also see that an underflow, in this case, during the subtraction is not possible because we are using Solidity 0.8 and there is this time no unchecked block here. So with that, we can say that it is not missing a zero address validation. It is not susceptible to an integer underflow, and it also does not have an incorrect balance update, which means that it is the none of the above. Continuing with question number 7, it says that there are security concerns with the Secureum's underscore do safe transfer acceptance check. And these security concerns are that there is an is contract check on the incorrect address. So is contract is probably a function that is being passed an address, and this address is potentially incorrect. Then B, there's an incorrect check on a return value. So there's probably some external call which returns some value that we should check. And C, there is a call to an incorrect is contract implementation. So this function that we're calling to check whether this address is a contract or not is apparently or potentially not correctly implemented. So what would this do safe transfer acceptance check function, what does this do? And why does it have so many checks and calls? Thing is, if we transfer a token like this to a contract that does not support ERC1155 tokens, which is very likely because those are not very widely used, then these tokens would basically be stuck in this contract, because this contract, nobody has access, has the private keys belonging to the address where this contract is being hosted, so nobody can use their private keys to make a direct call to the token contract to transfer them. And if the contract also isn't aware or doesn't know how to use these tokens, how to make a call to these tokens, then it also means that this contract cannot call the transfer function on this token contract to move these tokens, which means that transferring these tokens to a contract that does not support this ERC basically means that these tokens would be stuck at this address of this contract. That's bad. We want to avoid this if possible. And the way that we do this is that we first check that this receiving address, the receiver of these tokens, is a contract. If If they are not a contract, then we can just assign them directly, because that means there is probably someone who has a private key for the receiver address, and therefore we won't bother with any other checks. But if it is a contract, this returns true. Then we make an external call, and this external call is to some special function that's basically responds with some value that says, yes, I am able to handle ERC1155 tokens. And then this return value that says this basically needs to be checked whether this response is as expected, because of things like default, like fallback functions. It could be that a contract that we're calling, it implements the fallback function and returns some other values or no value at all, and therefore we have to make sure that it returned what we expected, that it returned a response that stands for the fact that it supports the 1155 tokens, and it cannot stand for anything else basically. So we need to check that in the return value. And well, the isContract implementation needs to be correct so that we can correctly assume that what we are calling is actually a contract. Okay, so let's take a look at the implementation of this function. And it is right here. This is an internal, no, a private function, where it first checks if contract is contract for the to variable. And the to variable is the receiver. So the address being passed to this isContract check is indeed correct, because we want the receiver to be checked against this. Then we can see that it makes a try, it makes an attempt to call this receiver, and it calls its on ERC1155 received function. This is a callback function basically. And then in the response, it expects the response to be this on received selector. So basically this receiver, this receiving contract can react that on the fact that it received a token, and it then needs to return the selector, so the 4 bytes of the hash of this function selector, or of this function. It needs to return this as the response, which is a very specific thing. This is very unlikely to happen by accident, even though it's just 4 bytes. And only then it is accepted. That is the intended way, but we actually can see that this is not quite correctly being checked here, the return value, because what it is doing is that if it is exactly the selector, then it reverts. This should not be this way around. This should be, if it is unequal, it should check that the response is exactly equal to the selector, and only then it should not revert. But it does the opposite here, so that's bad. But it does call the correct contract. And then the isContract implementation itself, so this check, it is checking whether the account, so the account in this case would be the to address. The account has a code of length equal to 0. And this 2 is not correct, because if it is equal to 0, that means it is not a contract, but this function is called isContract, and it should return if the length of the code at this address is not equal to 0. If it is larger than 0, then it is an account. But here it returns true that it is an account for the length being 0, which is exactly the opposite of what we need. So those are definitely 2 issues here. So let's go back to question 7. The security concerns are: the isContract check is made on the incorrect address. This is not correct, because it is made on the to address, which is what we want. Then B, the return value is being checked incorrectly. That is indeed a fact, because it is expecting the response to be a selector, but then it reverts, which should be the other way around. If it is not the expected function selector, then it should revert. And finally, we have C, which says that it is calling the incorrect an incorrect isContract implementation. And yes, the isContract implementation here, this check is definitely incorrectly implemented, because it is returning true for addresses that are exactly not contract. It's doing the opposite of what we need. So therefore in question 7, B and C are the correct options. We can finish up this race with question 8, which says that there are security concerns with the is-contract implementation. We've just talked about the is-contract function. We've already seen that it has an incorrect operator in the comparison. The operator currently is an equality operator, but what we actually need is an inequality or a bigger than, greater than operator, because we want this function called is-contract to return true when the specified address has a code size that is larger than 0. Then it is a contract. Therefore, B is correct. There is indeed an incorrect operator. Then we have A, which says it has an incorrect visibility, and C that says that this entire function is unnecessary because Ethereum only has contract accounts. And that is definitely not true, because we know that we have externally owned accounts, which are EOA accounts, which have private keys associated with their address. We have contract accounts, and we have accounts that are neither, that nobody has found the private key for, and nobody has deployed a contract there yet. So there are contracts which are neither of those, even though you cannot really distinguish EOAs from addresses that do not have a known private key associated with them. But we can for sure say that C is not a correct option. So in the end, there's only A left, which is about the incorrect visibility. So let's take a look if that's true. Here's again the is-contract function, and it is internal. And that's fine. And honestly, there is a security concern with this view function. Is very unlikely either way. Even if this would be public, then other contracts could call this function why ever they would do that, to check whether some address is a contract or not, but it would be much cheaper for them to just implement this themselves, and there's no state update in here that would give an attacker any attack surface here to exploit. So it is utterly irrelevant which visibility this has, and therefore A is just fine as it is. And that means that for question 8, B is correct, and that was race number 5.